Okay, hello. So let's look at some actual code for impact. And we're going to compare the code of writing in a global monolithic way, as opposed to splitting up the scope of your state and logic and see how that actually looks. So I have this silly little application here where I've just constructed some state and some management of that state, which kind of surfaces some of the issues of doing global state management. And basically, there's a page called dashboard where you can toggle something. And then if I go to projects here, you see that it's loading up a project. It shows that project. If I change this and I blur it, it actually changes the title and it changes it to uppercase because the project is awesome. And then if I write redirect here, we redirect back to the dashboard. Like, this is very silly stuff, but as we dive into the code, you might see that you do certain things that kind of creates a friction for you, and it's just difficult to understand why that friction occurs. But I hope by showing you the impact implementation of this, it starts to become more obvious why there is actual friction working with global state management as well. So let's see here. Let's close this. Let's go to our global store. And I've actually implemented the global store using impact because I'm just using a single hook. So what we can see here is that I've created this project DTO, which is our project entity with an ID, title, and if it's awesome or not. And then I have a type, a page type. And you might organize this differently in your global store, but the point there is that we have two different pages. We have a dashboard and we have a project, and there's certain state that's available and should be managed when we're on the dashboard, and other state that's accessible and managed when we're on the project page. And then I added also a not found page just to be very explicit. And the actual state here is that we're on this page, and then depending on the page, we have certain state available. And then I also have this projects record, which kind of acts as our cache for the projects. And I'm using a very traditional state for this. And you might know this from like just manually doing data fetching in global state stores yourself. Or if you use something like use query and those kinds of solutions where we might have the data of a project ETO or not. We have a loading state and we might have an error. Then for the actual routes, I'm just using a client-side router. In a global state store, you would have to implement this on the outside of the store. But because we're using impact and our stores are encapsulated by a function, we can actually create the router within the store. Other global state stores has like their own like plugins to provide routing data to your state store. But in Impact, that's not the case. Like, you use whatever routing solution you want. So here we can see I'm actually instantiating the router, and I'm instantiating the state of the store. And I'm using a signal for that so we can observe the changes. Where we just start on the not found page, we don't have any projects. And I'm using the use cleanup hook to dispose of the route listening. And the route listening is running this handle page change. And immediately we run that handle page change to look at the current route and put our state store in the correct page state. And the handle page change basically takes a route from our router, which might not be there because you might be on a route that we haven't defined, where we say if the route isn't there, we're going to go to the not found page. If it's the dashboard route, we go to the dashboard and we're not showing something. And then if we go to a project, we use the route params and the ID that is part of the URL to set the ID of the project we're looking at. Okay, and then from this hook, we return the actual state, and we return some logic and some interaction with this state. So for example, we have toggle something here, and now we're already starting to see where things get a little bit iffy, because the toggle something logic is really only available when you're on the dashboard page. But when we define things globally, we have to check, like, are we actually on the dashboard page, so that we can get the correct typing, and also ensure that we're not overriding anything. So for example, a case here could be that someone was calling this toggle something, and we would on the project page, and then we would actually change the page, for example. And this is like an important point, is that it's not only the complexity of your code and your state management across components that makes Impact help you. It's also the size of the team. Like, you have to remember that it's not necessarily the person who writes the code that owns and manages the code forever. Like, there's other developers who also gets into the code base. But yes, and then we have a fetch project method here. And what we do here is that we just check if we already have the project in our state. We could decide to just fetch the project regardless. This is about like how you want to do it. But in this case, I decided to, if we have the project in the cache, we're going to use it. And then we, if we don't have it, we go in and we set the project to a loading state. We go and grab the project, we insert the data and set the loading to false. And if there's an error, we set the loading to false and we give it the error. Now, as you saw from my awesome demo, we also allow you to update the project title. But again, like, since this logic is globally defined, it doesn't know that we're on the project page. Like, you know as a developer that you will only call update project title when we're on the project page. But the code doesn't know that. So you have to like create these fake validations to make your code and especially typing behave. Where we now make sure that if we're not on the project page, we don't do anything. We should probably throw an error here because you're calling this method in an invalid state. But regardless, we go in and we see if we have a project, because that's also a thing. Like, we don't know, the code doesn't know that there's a project there. Like, you know there's a project there as a developer because we just mounted a project on the project page, and you can't call this method without like mounting the project page with an actual project. But again, it just shows you how global definitions makes your code unaware of the actual context of your application. So we have to have this like kind of fake check here, where we again should probably throw an error to help the developer understand that they're using this method in an invalid context. Regardless, everything's okay here. We go in and we update the state of the project with a new title, and we check if the project is awesome. Because if the project is awesome, we want that title to be uppercase, or we use it as lowercase. And the reason I inserted this is because you might say that, why do you even manage caching in your store? And the reason is that when you use solutions like useQuery or similar solutions, that data is only available in your components, right? If you wanted to access, let's say we fetch the project in a component using useQuery or whatever, you wouldn't be able to access that project inside your state management that's external to React. And that's why I put it here, because you do want all your state to be accessible, right? And then we have this silly check where a new title is redirect. We use the router to go to the dashboard. And the reason I inserted this is not because you necessarily want to change route when you change the title of a project, but because you have dependencies to things outside, like side effects. It's not only about state, it's also triggering stuff, right? So if you were to do this in a different global state management solution, you will probably have to put this logic outside in a component somewhere. But then you don't see the full picture when you go into updating a title. There's just some component somewhere that actually changes the route because of that. But we want to co-locate all of this logic together. Okay, so that's the global version of this, and let's look at how the app actually looks. So what we're doing here is that we have our global app, and the global app is using the global store we created. And what it does is check which page we are on. If we're on the dashboard page, let's return the dashboard page. If we're on the project page, let's return the project page and give it the ID. And if we're none of those pages, we just return not found. And this shows something like a side note. This is why, at least for productivity types of applications, I always lean on client-side routing, because it's very straightforward to do that. There are benefits to doing like a component-based routing solution, but then you choose to move your routing outside of the rest of your state management, kind of as if they're not that tightly connected. But at least for productivity apps, they are typically very tightly connected. Yes, so let's look at the dashboard page first. So now we're using our global store. But again, we see this issue that this component this component knows what page it is, but your store doesn't know what page it is. So when you consume that state, you have to check, are we really on the dashboard? And again, we should probably throw an error here, because this shouldn't happen, right? You shouldn't be able to use the store in any other context than being on the dashboard page. And then we have normal logic here. We can toggle something, and we can use the state as normal because we had our check here. Moving to the project page, we get the ID here. And what we want to do here is see if we have a project. And if we don't have a project, we want to go and fetch that project. And we're doing that using an effect. So if we don't have a project, we go and fetch that project. And then our state is going to update. So if we don't have a project, if it's loading, or if we don't have any project data, we're saying that we're loading the project. If we have a project error, we're going to return an error. Or at the end, we know that we have project data, and we can pass that into the actual project component. So this is also a thing about, again, using solutions like useQuery and similar. You always get this unknown state of the project in this case. You don't know if it's been loaded already. So if you were to consume the same query in a nested component, you would still, even though you know that the project has been loaded, you would still have to make these checks to make the typing happy. Now moving on to the project itself, we can see that we use the project to insert the initial title, which we use component state for, where we can change that title, and then we can update the actual project title with this new title. Not found, not very interesting. So now you've kind of seen what kinds of issues, I've kind of been pointing to the issues that we have when we think about state management in a global context. So what we're going to do now is rather look at the implementation in a real impact way of doing things. So as you can see, I have a folder here called hooks. And I've split up the responsibilities of what we're trying to do. So for example, we have the router. So in the router hook, we create the routes. It's the same routes. And we insert the route specifically into a signal, so that whenever the route changes, we just update that signal with the new route. And then we return the current route by returning the value of the signal. And then as we think about this as like a public API, we are also creating a small abstraction to open the dashboard and open the project. So we're not using the direct API of the router. We make it domain specific. So any consumer of this hook consumes it in with the domain of the application. Yes, so now this router can be used by any component, and it can also be used by any other hook. And that means that we don't really need to expose a page state anymore. We have our router, and that is what defines what page we're going to trigger. Now we also have something called use API, and here we can see our project DTO definition again. And we can see that we decided to put our projects cache into the API. This could have been a separate hook if we had complicated caching logic. Maybe we wanted our API to just be about fetching data, and then we would have like a use projects cache as a different hook to manage the caching of projects specifically. But what's interesting here is that we're keeping these projects in a record where we use a suspense promise. And a suspense promise is a primitive coming from Impact that allows you to consume promises in React as it's planned to be supported with the new use hook. I'll get more back to that. And then this suspense promise doesn't just hold the data, it actually holds a signal with the data. And that is just a decision by me because I want the cache to always be the truth of the data. So regardless of whatever other hook changes that signal, maybe we would even have like an internal subscription updating that signal in the cache. It will always be the source of truth, and any consumer will be able to observe those changes and make sure that the UI is up to date. So the way we fetch a project here is basically giving it an ID. If we don't already have the project, we assign the variable, we update the project's cache, and we create a suspense promise from fetching the data. And then we put that data into the signal, which is then stored in the cache. So now we were able to not, because we were previously in a global context, we will kind of have to find typing for both the dashboard and the project page. But now we aren't going to make these hooks global. They're going to be used specifically for each page. So now we can create a hook that's called dashboard. And we have a signal reflecting that is showing something. We return that with a getter so that you can just access the state. And then we allow you to toggle that state. Going to the project, we can see that now we are going to expect to receive a signal of a project DTO. Again, I could have chosen to just receive the data and rather create the signal inside the project here. But as I said, I wanted to have like a source signal in the cache. So regardless of what's consuming that specific project DTO, it's observable and it's kept up to date. So what I'm doing here instead is that I'm returning getters for the different properties I want to consume from that project DTO. In the update title, we again get a new title. And here I'm also showing you how these signals support the Immer API, meaning that if you assign a function to the value of a promise of a signal, you get the current value, and you can update it using normal JavaScript mutation API, and it will return on like a new reference, like it's immutable. We have the same check here, and then we again check new title for the redirect. But as you probably noticed now, we don't have any checks of what context we're in. We know the context, we implement it knowing that context. And what we're going to see now is that also our components will consume these knowingly about the context. So let's see if we can look at the app here. And what we see here now is that we are creating our providers of these hooks. As I said, the dashboard hook is only going to be consumed within the dashboard page. The project hook is going to be consumed within the projects page. And then we also have these two global hooks, the use API and the use router, which will allow any page or component to consume regardless. And in our app component, we now return the pages with the global hooks provider. So now pages and any nested component can consume these two hooks. Looking at the pages now, we don't consume our global state store anymore. We just consume the router because the router knows what page we're on. And if we have a route and that the name of that route is dashboard, we return the dashboard with the dashboard hooks provider. If we have a route and the name is project, we actually return a suspense boundary. We'll get more into why we're doing that. And then the project page passing in the ID of the project, or will return not found. Now on the dashboard page, it's as you would expect. There's no checks here. We're just consuming our dashboard hook. And we have access to toggle something and the state we defined. On the project page, what we're doing on the project page is to load the project. And the thing is that since we're using a suspense promise, we can just call fetch project. And with that returned suspense promise, we can just call use on it. Like later, when React actually gets its use hook, you could rather wrap this thing in with the use hook. So this is just for convenience now, since we have our own extended promise. We can also add this method there to make it simpler to consume. So what happens here is when the project is actually loading, it throws to the suspense boundary that we wrapped around here, and it shows the loading state. But the really good thing is that now when this project signal is actually loaded, we have access to it. And we can now mount our project page wrapped with our project hooks provider, where it understands that the use project hook requires a project signal, just like we defined on the hook. So this ensures that you instantiate the hooks for this page with its initial required payload. And then we just run the project here. So in our project page, we can now safely use our project, and the project is what you expect. It's what we defined in the project hook. It has access to the ID, to the title, and the possibility to update the title. And that is basically it. I'm not showing like a side-by-side comparison here, but you can also dive into this sandbox and you can look at the code yourself. But I hope I made it clear how Impact allows you to split up the responsibilities of your state management and scope them to where they make sense. And for typing, this is a huge deal because you cannot, when you're in a global context, you have to type everything, if it's there or if it's not there, and basically makes all the rest of your logic completely miss out on what context your application actually is in. Every single component, every single piece of logic needs to verify the context they're supposed to run in. in terms of typing. Because you as a developer, you know implicitly about all these contexts, but your code doesn't. So yeah, that is one of the biggest things that Impact actually solves. Thanks for watching.